This video goes along with your Chapter 8.5 Day 2 notes from your algebra packet if you have it. If you don't have your notes packet, that's fine. You can still write some of this stuff down. So over the last couple of weeks, we've been working with standard form of a quadratic equation. So ax squared plus bx plus c equals 0. And only when you have a set equal to 0 can you actually identify your a, your b, and your c. Last week you went through and looked at stuff with the discriminant. So the discriminant is b squared minus 4 times a times c. And we came up with 3 different scenarios. If your discriminant is less than 0, so is a negative number, you have no real solutions. So based on your Algebra 1 skills, you are not able to solve it. That's an Algebra 2 thing. If your discriminant is equal to 0, you have one solution. And if your discriminant was greater than 0, a positive number, you had 2 solutions. So last week you did an investigation and you figured out those 3 facts, and then you applied them on your assignment. We're going to get back into solving this week. So when you are given the task of solving a quadratic equation, the first thing you should always do is find your discriminant. Because you should know, am I looking for 2 answers? Am I looking for 1 answer? Or should I not even waste my time solving this because it's not solvable? So once you've made that determination, if you have a 1 solution or a 2 solution problem, then it's time to actually solve it. If you're lucky enough and your quadratic does not have a b value, so your b is equal to 0, then you can solve by undoing the order of operations. So if you have something like 2x squared plus 2 equals 0, then you could undo the order of operations and solve that. Sometimes you can solve it by just pulling out a greatest common factor. So if you had something like 2x squared plus 2x equals 0, you can't solve that by undoing the order of operations because you have a b value. But both terms have a common factor of 2x. So if you factor the 2x out to the front, 2x squared divided by 2x is x. And 2x squared divided by 2x is 1. And now it's factored, and you can split it and set each factor equal to 0 and keep solving. Or occasionally you have to use a factor box. So something like 2x squared plus 5x plus 3 equals 0. And then you would set up your x, fill in your box, and you would come up with 2x plus 3 times the quantity of x plus 1 equals 0. So it's factorable. And then sometimes you hit a point where you have something like 4x squared plus 5x minus 2 equals 0. And you're like, okay, well, I can't undo the order of operations because I have a b value. I don't have a greatest common factor that I can just pull out to the front and get rid of my quadratic. Can I do a factor box? So is there anything that multiplies to negative 8 but adds to 5? Well, 1 and 8, 2 and 4, and those are my only choices, so there's no way my x would even work. So if you had already found your discriminant, you would know that you have 2 solutions. But maybe you're like, well, So you graph it. So if I type in the equation and I graph it, well, my window's not in a normal position, but you can see that I have one solution there and I have another solution there. So it clearly has two solutions. It's just I'm not able to solve it by undoing the order of operations or pulling out a GCF or doing a factor box. So this is where something called the quadratic formula would come in. So you need the quadratic formula because it is the fourth way to solve a quadratic, and it is the only way that always works. Always is one word. It's been a while. Some things don't change though. So the quadratic formula will always find you a solution. It's just not always your fastest route. So that's why we have the quadratic formula.